Hey guys, welcome to your first spiral review. On this spiral, we're looking at two different topics, linear functions and factoring, and then we're looking at piecewise functions and domain and range. This is going to be an ungraded spiral, so you will only get feedback instead of getting grades for these. But to make sure that you have as much of a chance to succeed as you can, we're going to go through this and help you get to where you need to be. Okay, so we need an equation for a line that passes through these points. So the first thing I need is some kind of a slope. And for that slope, we're going to do 5 minus negative 5 divide by m minus 3. And that's going to be 10 over m minus 3. Okay, we also need a point. I don't love having an m in there twice, so I might just use my other point. And that's going to give us y is equal to negative 5 and 10, that should be plus, over 5. Wow, I'm doing awesome with writing things today. M minus 3, and that's going to be times x minus 3. Okay, so we got to find the x and the y-intercepts in terms of m. In other words, we've got to figure out what it means to be an x-intercept or y-intercept, and then basically do that type of math out. Okay, so an x-intercept happens when y is 0. So I'm going to write this as 0 is equal to negative 5 plus 10 over, I almost wrote 5 again, m minus 3, and that's times x minus 3. Okay, let's get x by itself because that's really what we're trying to do here. We're going to add 5 to both sides. We get 5 is equal to 10 over m minus 3. I finally wrote it right. And that's times x minus 3. Okay, getting this further, we might multiply by the reciprocal instead of 10 over m minus 3. We multiply this by m minus 3 over 10 on both sides. Let me move this a little bit so I can do that. Then we got m minus 3 over 10. What that's going to do is on the right side cancel out, leave me with just x minus 3. So we get 5 times the quantity, m minus 3 over 10 is equal to x minus 3. Finishing this up for an x-intercept, we get 5 m minus 15. You could reduce that if you wanted to. And then plus 3 is equal to x. Totally fine to leave it that way. To find a y-intercept, which actually might be a lot easier for us, what we've got to do is then, I'm going to use a different color, set x equal to 0. So we've got y is equal to negative 5. Let me move this over a little bit. And that's going to be plus 10 over m minus 3. And x minus 3, well, 0 minus 3, which is just negative 3. So our y-intercept would be negative 5. Negative 3 times 10 is going to be negative 30 over m minus 3. Those look unpleasant, but because you don't actually need to solve for that, you could leave that as is. If those were actual numbers, this probably would be a lot easier for us to do, and it's probably more likely going to be like that on your spiral itself, because it seems like that's kind of a mean thing to deal, especially with the variable in the denominator. It's not as scary if it's in the numerator. Next up, we're dealing with some solving by factoring. And to solve by factoring, the first thing we want to make sure we do is bring everything over to one side. So this first guy is going to be 28x squared plus 3x minus 18 is equal to 0. I'm looking for things that multiply to whatever 28 times negative 18 is. I'm so glad I chose those numbers. So 28 times negative 18, that's negative 504. That's not that bad, better than what we did in class the other day. And add up to negative 3, or positive 3, I guess. Okay, well that's going to be negative 504 and positive 1. No. Negative 252 and 2. Nope. Does that work for 3? It sure does. Negative 168 and 3. Nope. Does that work for 4? Yep, that's going to be negative 126 and 4. Nope, 5 doesn't work. 6 should work. 504 divided by 6 is going to be 84. So negative 84 and 6. Still too far away. 7, I don't think works. Oh, it does. 772. I'm so glad I chose this number. Oh, I should have known that worked. So negative 72 and 7. 8's definitely going to work. So 504 divided by 8. We got negative 63 and 8. 504 divided by 9 is going to be 56. So negative 56 and 9. 10 doesn't work. 11 doesn't work. 12 should work. 504 divided by 12. We get 42, so negative 42, and we're still not even close. Hopefully you skipped around a little bit instead of following the exact sequence that I'm doing. 13 doesn't work. 14 should work. 504 divided by 14. We're at 36. 504, 36, and 14. 15 won't work. 16 will work. 504 divided by 16. Oh, it doesn't work. Good. 17 won't work. 18 might work. 504 divided by 18. 18 and 28. Oh, I should have known that from the problem. That seems kind of silly to me that I didn't realize that. And let's try 21, just to see if that works. 504 divided by 21, and we get 24. And we have a winner. Whew, that was a lot of work. You could kind of work your way through that a little bit more quickly if you kind of thought about what we need to do in order to get close to these values. So we're going to break this up. 28x squared minus 24x plus 21x minus 18 is equal to 0. That's going to factor into 4x and 7x minus 6, and 3 and 7x minus 6. So we get 4x plus 3 and 7x minus 6 equals 0, which means that 4x plus 3 equals 0. Therefore, x is equal to negative 3/4. And 7x minus 6 is equal to 0, which means that x is equal to 6 over 7. For the other problem, which I'm really hoping has nicer numbers, and it looks like it might, so that's kind of cool. First thing I might do is make things positive, because I don't like negative x squareds. So that might become 33x squared minus 23x plus 4 is equal to 0. From here, I'm trying to find things, and if I multiply this a times c, I get 132, and then that multiplied to negative 23. I'm going to kind of start from the middle here. So I know that 33 times 4 has to end up at 132, but those do not add up to 23. So let's try something else. Maybe do something with 11, because I know 3 and 11 go well together. And 11 times 12 would end up giving me positive 23. I need negative 23. Both those got to be negative. So we end up with 33x squared minus 11x minus 12x plus 4. We end up with 11x and 3x minus 1. We end up with minus 4 and 3x minus 1. So 3x minus 1 and 11x minus 4 would be our two factors. That's still equal to 0. 3x minus 1 means that 3x minus 1 equals 0, or x equals a third. 11x minus 4 means that that equals 0, or x is equal to 4 over 11. Next up, we've got some piecewise functions. You're asked to do a couple of different things here. The first thing you're asked to do is to find some values of this function. So g of negative 6, since negative 6 fits into this condition, the less than negative 3 condition, we're going to plug that in. We get negative 6 squared plus 1 is going to be negative 36 plus 1 is negative 35. For g of negative 3, well, that's this condition. And the answer for that's going to be 4. And finally, for g of 5, you might realize that that's going to be the last condition, because 5 is greater than negative 3. We get 3 times 5 squared minus 14, which is 75 minus 14 is 61. Okay, so we've got to find any x-intercepts. X-intercepts happen when y is equal to 0. One of the things that we got to think about is that this could theoretically happen at any of these three parts of our graph. So we've got to do all three of these pieces and set them all equal to 0 and see what happens. So for the first condition, we got negative x squared plus 1 is equal to 0. If I move x squared to the other side, we get x squared is equal to 1, and that means that x is equal to plus or minus 1. We have another piece of this, is that if this is true, but that only happens when x is less than negative 3. Neither of these fit that bill, so this part doesn't work. So the weird thing here is we're going to end up with things that may or may not work based on the conditions that are in the problem. For my second one, we're looking for when y equals 0, okay? So 0 equals 4. That one doesn't work either because we got a statement that was not true. And then finally, 3x squared minus 14. And this is only going to work when x is greater than negative 3. So if we get things that are, we're good. 3x squared minus 14 is equal to 0. I might say that x squared is equal to 14 over 3. And x is equal to plus or minus the square root of 14 over 3. If you don't have the square root of 14 over 3 memorized, then you might throw that on a calculator and get there. We're looking at plus or minus about 2.1. Since those are both bigger than negative 3, those are our two x-intercepts. Okay, as far as continuity goes, we're beginning to look at this just in terms of the numbers that we have here and basically plugging things in and see what happens. Our first break happens at negative 3. In fact, that's our only break. So let's plug things in. We get negative 3 squared plus 1. That's going to be negative 9 plus 1 is negative 8. Negative 8 does not equal 4, which is the next piece of our puzzle. So that's kind of immediately not continuous. It's not continuous because the first stem doesn't equal the second part of this. You don't have to do any more math to figure that out. Finally, we're going to look at our domain and range stuff. This week it's just going to be graphical things. So we've got to take a look at this and find the domain using interval notation. Well, we know we're starting at -6, going to +6. The domain would be -6 to 6. The range, we're looking for the lowest to the highest values. We're starting at -7. We're going up to +4. Intervals that are positive, okay, so that means above the x-axis, and decreasing. That means we've got a negative slope. The places on here that are positive, I'm going to color in with red. And then places that are decreasing, I'm going to highlight with blue. So decreasing. And you might notice that we've got two places that are both of these situations. The first is the interval from -2 to -1. And on that interval, we're above the x-axis, but we're decreasing. We've got a negative slope. The other one is from 5 to 6. And on that interval, we are positive. We're above the x-axis, but we have a negative slope. Finding things that are negative, so that's below the x-axis, and increasing. Our first one is going to be that looks like it goes up to about 3.5 in the negative. But we're looking from -6 to about -3.5. And then we're going to see this again. That looks more like about 3.3, so maybe 3 1/3. So we're looking at from 2 and then about 3 1/3, I'd guess. I could figure out the exact thing, but I can't really tell where this thing hits exactly. So we do the best that we can to make some sense of that. And I've kind of colored over stuff, so I can't really see if that is clear or not. Okay, and that's all we got for today.